Hi everyone, I am here with another video on lists. This is about list slicing. So if you haven't watched my previous videos on lists, please do watch them and then come back here. So that is my sincere suggestion. Why? Because in other videos I have covered introduction to lists and then accessing elements of the list. So as a continuation to that one, I am starting this third video, so which is about list slicing. So in my previous video I have introduced list slicing and I thought that I should discuss that elaborately so that everyone will understand it in a clear manner. Extracting a portion of the list. So to extract a portion of the list we can use list slicing. So this extracting a portion of list is very important in data analysis or data science applications. For example, if I am interested in first 10 rows, I could extract only those rows by using list slicing. Similarly, for example, when I am considering features of a data set, I can exclude some features and I can consider only the important features. So features are nothing but columns in a data frame. So to extract the desired features also, we can use list slicing. So in that way it is very important. So list slicing is one flexible and powerful feature of lists available in Python. This kind of feature is not available in other programming languages such as C, C++ and Java. Let us get into the details. Extracting a portion of the list. To extract a portion of the list, I am considering one example here. The list contains the elements 1 to 10. I would like to get the first 5 elements. How can I get that? Print. For example, I would like to get the first 5 elements. The starting index of this is 0. The ending index is 5. What does this mean? This colon is a slice operation. 0 is the starting index, 5 is the ending index. So 0 means it starts at 1 and ending index is 5 means like range function, it stops at 4. So that means 1, 2, 3, 4, 5 will be printed. Let me run this code. 1, 2, 3, 4, 5 are printed. So as this is obviously starting position, I can omit this. Even then it will work in the same manner. Yes. Next. For example, I would like to get the last 5 elements of the list. How can I get it? So last 5 elements. So that means 6, 7, 8, 9, 10 are to be printed. So what is the position of 6 here? Position of 6 is 5. And what is the position of the last element? That is 9. I will be giving one extra here. 5 to 10. Let me run this one. 6, 7, 8, 9, 10 are printed. For example, we know that this 10 is obvious, 10 minus 1 is obvious ending position. If I omit that also, then it will be giving from fifth element to last element. Yes. So this is how we can extract a portion of the list. Now let us extract some middle part of the list. For example, I would like to print or I would like to access the elements 4, 5, 6. So how can I access those elements? 4, 5, 6. What is the position of 4? 0, 1, 2, 3. 3 is the starting position. What is the position of 6? 1, 2, 3, 0, 1, 2, 3, 4, 5. 5 is the position of 6, but we will be giving one extra. Like it works just like a range function. Then, so 4, 5, 6 are extracted. Then, sometimes we need to extract a portion of the list and that can be stored in some other list for later usage. So let us do that one. I will take L1. This is new list which will be generated or which will be created from the portion of L. So for example, let me consider first 5 elements should go to L1. last 5 elements should go to L2. How to get these last 5 elements? 5 colon, as I need not mention the last index. If I am going till the end of the list, I need not mention that ending index. If we are starting from the first element, I need not give the starting index. Now if you print L1 and L2, the first half is going to L1, the remaining half is going to L2. Then sometimes like a range function, we can also give step value to this slicing. So for example, I would like to get in L3, I would like to get the alternative elements. For example, I would like to get 1, 3, 5, 7, 9 into L3. How can I get that? Let me give the starting index as 0. What is the ending index? 10. What is the step value? 2. Let me print this L3. Yes. What are the values that are printed? 1, 3, 5, 7, 9. What happened here? The starting index is 0, ending index is 10. That means the whole list is considered and the step value is given as 2. If I do not give the step value in the third part of that slicing, the obvious step value is 1. So if I am mentioning it explicitly, then that like range function, that increment will happen. So now what is happening? So it is printing the first element, then its index is incremented by 2, then it is printing third, 3, 5, 7, 9. Suppose, as I told you earlier, the obvious starting index and ending index can be omitted. Even then it will be assumed as the starting index is 0, ending index is the length of the list. Then the same is printed here. In the same way, we can print the reverse of the list. For example, let me take L4. L4 is L colon colon minus 1. If I give the step value as minus 1, it will get the reverse of the list. Yes, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Sometimes if there are two lists or 2, 3 lists, we can create a new list by combining some elements from one list and another list. So let me experiment with that one. So let me consider L1 is 1, 2, already I have taken that. Okay, let me take this 4, 5. L2 is 6, 7, 8, 9, 10. I would like to construct L3 as first two elements from first list, first two elements from second list. Now, if you print L3, what will be printed? Let us do this. Sorry, this is wrong. This is something like, yeah, I took L there, it is not required. You see, L1 is 1, 2, 3, 4, 5, L2 is 6, 7, 8, 9, 10. The first two elements of L1 are 1, 2, the next first two elements of L2 are 6, 7. We have created a new list by taking some portion from L1 and some portion from L2. So this is how we can extract a portion of the list. And filtering, I have explained how we can skip some elements and then take. So if you are familiar with the list comprehension, we can show this filtering and all in a much effective way. In the next video, I will be discussing about list comprehensions. Then we can discuss this slicing and all there also. Next, let me consider another case. Using this slicing, to modify the elements of the list. For example, I would like to remove some elements from this list. I will be using list slicing. So L equal to L, sorry, L of first 5 elements I would like to remove, colon 5 equal to L. Now let me print L. What will happen? The first 5 elements will be removed from the list. So why? Because I made that portion as empty. Let us run this code and see. You see, now in L only 6, 7, 8, 9, 10 are there. The first 5 elements are removed. Okay, so this is how we can remove. Suppose I would like to add some elements. So L in the first position, I would like to add some elements. So what are those elements? 1, 2, 3, 4, 5. Don't worry about the size of this slicing and then the size that I am giving here. So it will accommodate all these values. Now we will be getting, I will print L here. After adding some elements, I will print L again. You see? Excuse me. You see, so I have started with the 0 and ended at 0th position. We have inserted 1, 2, 3, 4, 5. So earlier list, what was the element that is there in that 0th position? 6. That 6 is replaced with 1, 2, 3, 4, 5. This is how we can modify the contents of the list using slicing. Next, let us consider negative indexing. In our previous videos, we discussed that lists allow negative indexing and the same feature can be used for slicing also. For example, I would like to get last 5 elements from this list. I will be applying negative index to get that one. Print L. Last 5 elements means minus 1, minus 2, minus 3, minus 4, minus 5. You see, we have got 6, 7, 8, 9, 10. I have not given any ending index here. For example, I would like to get the last element. So we know that by using minus 1 we can get the last element. Suppose if we want to get a portion of the list, middle portion of the list using negative indexing, how can we do that? 10 is at minus 1, 9 is at minus 2, 8 is at minus 3, 7 is at minus 4, 6 is at minus 5, 5 is at minus 6, something like that. So I would like to get 5, 6, 7. How can I get that? Minus 5. Can I get, no, 10 is at minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So this is minus 6 minus minus 6, minus 7, minus 8. Minus 8 means I should give minus 9 or minus 8. Let us just check. I would like to get 5, 6, 7. So we didn't get it. Why? I am starting at minus 6. Okay. Shall I give minus 1 here? 5, 4, 3. That is reverse I have got. Let me just try with another one. Minus 6. Minus 6 is 5. Shall I give the starting value is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus 6, what will happen if I give something like this? Minus 9 to minus 6. Let me try this one. We got 2, 3, 4 minus 9. Okay. Okay. Smaller value should be given first. Okay. Then to get this 5, 6, 7, what should I give? 7 minus 9 is this one, minus 6, it will go up to here. To get 5, 6, 7, what should I give? Minus 1, minus 2, minus 3, minus 4, minus 5. This is minus 6. From minus 6, minus let me give, okay, minus 6 colon, this is minus 3, minus 1, minus 2, minus 3, minus 4, minus 3. Let me give this one. Let us see what is the output. Yes, we have got it exactly. This is how we have to use negative indexing. Then there could be one negative index, one positive index also. It will try to extract. For example, we would like to get 0 to up to what? Minus 3. How can I get it? Minus this one is at minus 10, minus 9, minus 8. Minus 8. Let me just print what will happen here. Yes, we got 0 to. Here what is happening? We are combining negative indexing and positive indexing. This can also happen. This negative indexing is helpful when we rotate the elements towards right. In the next example, we will see that one. Next, as an application to this list slicing, I am considering one problem. Cyclically rotate an array or list by k positions. So let us consider the given array as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have to left rotate by k positions, let us consider some k equal to 3. You have to left rotate by 3 positions. What is meant by left rotate? What will be the output for this one? If you do this left rotation by 3 positions, it should be like 4, 5, 6, 7, 8, 9, 10. The left shifted elements will go to the right hand side. So this will be 1, 2, 3. This should be the output if you left rotate the list by 3 positions. How can we use this list slicing? How can we exploit this list slicing to achieve this effect? So I will simply write like L equal to L of what is that k? K is 3 here. How to do this one? Up to from k to last position, extract from the list, then 0 to kth position. This will give the left rotation by k positions. Now let me print L. Let us run this code and see whether we get the desired output or not. You see, are we getting it exactly or not? Yes. So what is that I have done here? You take k. From k onwards, you extract from the list. Then from 0th position to k, you extract. Then you combine these two. That means to the first extracted list, add the second extracted list. This will do the job of left rotating the array or left rotating the list by k positions. Okay. Then how can we do this right rotate? This is given in LeetCode problem number 189. If you are interested, you can open that problem and you can submit this solution. This is just one-liner solution in Python. In other programming languages, it is somewhat tedious job, but in Python, we can do it with one-line solution. How to do this right rotation? So I will be doing something like L equal to L of, this is trick from my side, this is a tip I can say. Instead of positive k, take minus k plus L of If it is right rotate, just take minus k. Then print L. Let us run the output, run the code. Let us see. You see, oh, we have done left rotation already, and then we are doing right rotation by k, and it is giving the original list. Okay, this is functioning, but you may get confused. Let me just hide this. Let me not do this left rotation. We are doing only right rotation. You see. So when we do right rotation by k positions, the shifted right side portion will come and join in the left side. Okay, so this is nothing but right rotation. So this can also be done in another way, that is nothing but L equal to L of n minus k, where n is the length of the list, colon, plus L of colon n minus k. So what is n here? N is nothing but len of L. First you store the value in n, then use this one. So this should also do the same thing. You see, this is also doing the same. So the trick here is, if it is right shift, don't worry about n and all, just use negative indexing, minus k minus k. Okay, so you go and submit this solution in the lead code problem number 189. Okay, so this is cyclically rotating an array or list by k positions with the help of slicing. Next, similarly, I will be considering one more problem, that is reverse the array in groups. For example, if I give k equal to 3, the output of this must be like L equal to 3, 2, 1. That means the first 3 elements are reversed. Then the next 3 elements will be reversed. 6, 5, 4. Next 3 elements will be reversed. 9, 8, 7. As there is only one element left, that will come as it is. So this should be the output if we perform reversing the array in groups. That size of that group is 3 here. How can we do this? With the help of list slicing. For this one, I will be taking one for loop for I in range 0, comma. I will be taking n. N is nothing but length of the list. I can directly give here len of L, and each time that increment has to happen by k times. Then let me store the result in some res equal to some empty list. I will assume res is every time I will extract one group and I will reverse it. L of I colon I plus k. I will be extracting the group and I have to reverse that. No. How to reverse a list with the help of list slicing? I introduced this earlier in one example. So we can do like this. Now if you print result, we must get the expected output. What is k here? 3. That means the group size is 3. You see exactly what we expected, that is printed as it is. This is how we can reverse the elements in group wise using list slicing. Suppose here you may get a doubt like, if there is only one element left over, it is coming as it is. Suppose there is one more element. Let us assume 11 is there. Can we get the same? Yes, obviously. You see 11, 10, that is also reversed. Okay, so this is how we can do this, reversing the array in groups with the help of list slicing. This is also one important application, and this problem you can find in Geeks for Geeks. You just Google it and you can go and solve this problem. Next, copying a list. What is meant by copying a list? Normally in other programming languages, we can copy one array into other. But in Python, suppose if I do something like this, what will happen? we expect that L1 to be copy of L, but what will happen is, let me print L and L1. Uh, they will be stored at the same location, just the names are different. It can't be a copy. So let me do some manipulations to L dot append some 11. So to L I have added one more element, but this copy I have made earlier. So if I print L and L1, I must get different L and L1s. What will happen? Let us see. Okay, let me print. You see, before copy, before this append operation, they are same. Okay. After append I am making only to L but not to L1. Even then, L1 is also updated. This is what happens in Python. Okay. So how can I create a copy to the given list? We can use copy method, or else we can use list slicing to do that job. Suppose if I do like this, what will happen? Let us see. You see the difference. So I have printed L and L1 after copying. Then I have made changes to L. Those changes are not reflected to L1. That is what I have demonstrated here. So to copy a list into another one, what is the best approach? Using this slice operation. This also has many applications, like in competitive coding. They may ask us to do in-place sorting, in-place reversal, such kind of tasks will be given. In those cases, you can take one temporary array, you can do the job, and the contents of that temporary array can be shifted to the original array. And then later you can remove that temporary array. So that is one trick to do something in place. Okay, so instead of carrying out many tricky operations, many complex operations, you can take one temporary array, you can do the job, and that temporary array can be copied to the original array. Then as per their expectation, the result will be available in the original array. That is one tip from my side. You can use that in competitive coding. Okay, so I hope you understood the content presented in this video. So let me just quickly summarize what we have covered in this video. So first I have this whole video is about list slicing. This is in continuation to Python lists part 2. This is part 3. So first I have demonstrated extracting a portion of the list and filtering some elements. Then I have demonstrated how to modify the contents of the list using list slicing. Either that could be insertion or deleting the elements or modifying the elements. Once I discuss list comprehension, I can also tell you how to modify the individual elements of the list. For example, 1 can be incremented by 1 and it becomes 2, like that. So with the help of list comprehension and slicing, we can do all those things in an easy manner. Next, slicing with negative indexes. We have experimented with various examples here. We can even mix up positive indexes and negative indexes. Then, to further demonstrate this one, I took two applications. One is cyclically rotating the array by k positions, either towards left or towards right. Then I have taken reversing the array in groups with the help of list slicing. I hope you understood the video. Try to solve all these things, whatever I have discussed here on your own. And so if you like the video, share it among your friends and subscribe, and please comment which part of this or which slicing method that I have used here is interesting for you. Okay, so thank you.